All right, this is number 8 from the practice exam. It says, what is the major product for the following reaction? Right, and they give us this molecule here with the double bond. And first we're going to react it with BH3 in THF. And then we're going to react it in peroxide and NaOH. So this is, I know already from here, I know from first reacting with the BH3 in THF and then reacting with peroxide and NaOH, that what I'm going to do is I'm going to get an alcohol. I know that. I'm going to get an alcohol from the alkene. So an alcohol is going to appear where the alkene is through hydroboration, which will be the first step. And then the second step will be oxidation. I also know that it will be anti-Markovnikov, syn addition, and it will be hydration, meaning that a whole water molecule will be attached. 2 H's and 1 O's will be attached. This mechanism is the same. If you want to see a little bit more about this type of mechanism, go to number 6 in this same series, the practice exam. So step 1 to do this, right, is hydroboration. So when I do hydroboration, let me just rewrite this molecule. Here's where the CH was. This CH, right, attached. The CH is attached to 1H. And right here we have a CH2, right? So here's the CH, and here is, okay, that's where the CH2 was, and to that the bromine attaches. So this complex, the BH3 complex, comes in, breaks this alkene, and then there's anti-Markovnikov addition of the hydrogen. You would expect a hydrogen to go to the carbon with the 2 H's, but it goes to the one with the 1, and the bromine H2 goes to the one with the 1. So that's step 1. We get this complex. So then step 2 is oxidation. The only thing that happens in oxidation, so that stays the same, that hydrogen stays there. And then where the boron, where the boron atom was, you just replace it with an OH group, right? So now we know we got an alcohol, right? We got an alcohol from where the alkene used to be through hydroboration oxidation. It was anti-Markovnikov addition. It was syn addition. These had to be added to the same side of this bond. None of these carbons are stereogenic. None of these carbons are attached to 4 different molecules. So, none of these molecules are attached to 4 different I think that's the logic behind it. None of these molecules were attached to here. None of these molecules. This molecule is attached to 2 H's. This molecule is attached to 2 H's, so they're not stereogenic. So we don't need to worry about enantiomers. So on the test they said something plus enantiomers. That was my reasoning why I knew I didn't have to worry about that. So there was syn addition. They're on the same side, and it was hydration because a whole water molecule was taken in, right? This H was added and this OH was added all together. It's a water molecule, so it's hydration. Now the test got a little tricky, and what they did is they just kind of like reversed the molecule from the way they showed it to you. So here the OH is here, and then you keep going, and then the double methyl groups are here at the end. So they just flipped it around to have fun. So the answer is A. Right?